Welcome to your term to review for transport. So for this set of quick notes, we're going to be talking about two main types of transports and discussing some similarities as well as some differences between the two. So the two main types of transport that we're going to be focusing on are a type of transport called passive and then another type of transport referred to as active transport. The main difference between these two types of transport just has to do with how things are moving relative to their concentration gradient. And remember, we've talked about concentration gradients before. All a concentration gradient is a difference in the amount of substance or solute you have in the solvent on two sides of a membrane. So let me give you an example. Whenever we're talking about passive transport, we're also always talking about moving things with the concentration gradient or going down the concentration gradient. So we're always moving from a region of high concentration to a region of low concentration. And because we're doing this, we can say it's kind of like rolling a ball down a hill. So if this is my ball, I know the ball can roll down the hill and it's super easy and it requires no energy because things are going to move on their own in that direction automatically, so it doesn't require any energy. On the other hand, if we're talking about active transport, we still have a concentration gradient here, but instead of going with the concentration gradient or down the concentration gradient, we're going to be pushing things up the concentration gradient. So we're going to be going from low to high. Now when we do that, what we notice is that we actually need something to actually power the move from low to high. So we're going to need a pump. And this pump that we're going to need is actually going to be a protein. But in order for that pump to do its job, we actually need to give it something. It needs some energy. And the energy that we're going to give this pump is going to be ATP. And we've talked about AT before. ATP is the molecule of energy. So when we give this protein pump ATP, we're able to push things against the concentration gradient. So for this example, it's like if we have the same hill with the same ball, but this time we're taking the ball from the bottom of the hill and we're pushing it up to the top. So those are the two ways in which things can move. Now for active transport, that's pretty much all you need to know. Things are always moving against the concentration gradient and they always require energy. If I were to show you a visual of what this looks like, if we have our cell membrane, and remember your cell membrane is a phospholipid bilayer. So here's my cell membrane here, and I'm going to have a transport protein built inside of this particular membrane. And I need that transport protein because I need something to serve as my pump. I'm going to go ahead and put in my fatty acid tails here. So if this is my cell membrane and I am showing you my solute on one side of the membrane versus solute on another, all you have to do is look at the relative concentration and where you see more. So if I'm looking at this particular picture, I can see that it's definitely high on this side, so I have a high concentration gradient here, and I have a low concentration gradient here. So if this is active transport, we know we're going to go from low to high. So that means in this particular instance, I am going to be moving things against the concentration gradient. So I'm moving in this direction and I'm pumping things to where there's already a lot of it. So I'm moving from low to high and it requires energy in order to do it. And the energy again comes from ATP. So that's an example of active transport. Now if we hop on over to passive transport is just not that simple because we have three different types of passive transport that you're responsible for knowing. The first type of passive transport that you need to know is something called simple diffusion or just diffusion. And with diffusion and with all of these forms of passive transport, we're moving things from high to low, but it's just a question of what are we moving and what do we need in order to move it. For diffusion, all we're doing is we're moving small substances from a region of high concentration to low concentration. Again, because it's passive, it doesn't need any energy because we're rolling a ball down a hill. The next form of passive transport that you need to know is something called osmosis. And osmosis is very similar to diffusion. In fact, osmosis is a special case of diffusion in which we are moving water. So we're moving water down the concentration gradient, or we're going from high to low, or we're rolling the ball from the top of the hill to the bottom of the hill. The last type of transport, passive transport that you need to know is something called facilitated diffusion. And facilitated diffusion, if we focus on this word facilitated, to facilitate something means to help. So in this case, for facilitated diffusion, we actually need a helper protein. So we're still moving things from high to low, but we're, in this case, tending to move large substances, and because we're moving large substances, we need a helper protein in order to get it done. So in that case, facilitated diffusion and active transport have something in common in that they both need a protein to move things from one side of the membrane to the other. But just like in this picture, I'm going to go ahead and set myself up again. When we're talking about passive transport, again, what we're going to do is we're going to pay attention to the concentration gradient. We're going to see where things are high versus where they're low. So if I look here, I can go ahead and fill this in. I know that I am high on the top. I have a high concentration here and I have a low concentration here. And if I know that it's passive, things have to move with the concentration gradient. So things have to go from high to low in this case. So those are the main forms of passive transport that you need to know, and these are the main differences between active and passive transport that you need to know for your assessment. But you also have to be able to take this situation and apply it to very specific circumstances that you might see. So let me give you an example. These are some of the harder ones that you might see on your assessment. So sometimes what they'll do is they'll show you a cell inside of a beaker of solution. So here's my cell. And what they'll do is they'll tell you, let's say that your solution that your cell is floating in is 15% NaCl. And we'll say that it's 5% NaCl inside of the cell. Now, something to remember here, anytime we tell you the percentage of one thing and we don't tell you the percentage of another, always remember what we said about 100%. Each area needs to add up to 100. So if I have 15% NaCl here, that means that the remainder has to be water because we have to add up to 100. So 100 minus 15 is going to give me 85. So that means I have 85% H2O. And if I look on the inside, if I have 5% NaCl, all I have to do is subtract 5% again from 100 because this outside needs to add up to 100, but the inside also needs to add up to 100. So that means if I have 5% NaCl, I know that I have 95% H2O. And then if I have to figure out what's going to happen to the cell, in this instance, all I have to do is ask myself is, where do I have a higher concentration of water? Because whenever we're talking about transport, essentially things always want to be equal. And if things want to be equal, the only way to do that is to move from high to low. That's why it doesn't require any energy. So if I'm high on the inside of H2O, low on the outside, I know things are going to be moving from the inside of the cell to the outside of the cell. So in this case, the cell will shrink. Here's another example that brings up a new term. So in this case, if I show you the same setup, so I have a cell inside of a solution, but inside of my cell I have 30% NaCl, and on the outside I also have 30% NaCl. Again, I need to think about my concept of 100. Everything has to add up to 100. If I'm 30% on the outside NaCl, that means I need 70% H2O. And the same thing is true on the inside. But here, if we're trying to figure out where are we high versus where we're low, we'll notice that these are actually the same. So there's the same amount of stuff on the outside as there is on the inside. So things are going to be moving in both directions at the same rate. So the cell will stay the same. And the reason why it will stay the same is because we can say that this is in something called equilibrium. And equilibrium sounds like the word equal, meaning it's the same on both sides. So we won't see any particular movement from one side to the next. All right, those are the big deal topics for transport. Go ahead and use your notes to help you see if you can go ahead and fill out the information that you see on your day sheet. Good luck, guys, and thanks.